week one, day one, everything we do comes down to HTML, right? No matter what happens, it's all about the HTML. That HTML is generated from somewhere, right? We've been generating our HTML from our React app. But really, our React app always needs content to actually do something, right? Sometimes it's static content. Sometimes it's like, hello, welcome to my site. That's cool, right? Other times, it's dynamic. Like your projects this weekend, where you had to pull from an API to display a list of dynamic data, right? That data has to be stored somewhere. That data is stored inside of a database. This is where we actually store the data. So if we go back to our car analogy, we're building a car. We've done the HTML and CSS, that's the outside, that's the frame, that kind of what holds it together. We've talked about the inside, right? That's the React, that's the stuff that the user sees and touches and interacts with. Now, we're going to take a couple of jumps, and we're going to talk about the actual engine itself. We're going to start working from the inside out. So by the end of this week, we'll be making APIs that we can talk to.
This week?
Probably. If not this week, then Monday. I am recording. Yes.
I will forget all of this.
Yeah, right? But in order to make any of that work and be meaningful, we need some place to actually store our data. So like this weekend when you're working with employees, right? That means that there's a database that has all your employees listed out somewhere, right? This is awesome. So before we talk about the actual implementations, let's talk about what databases are in general. And there's two big branches of databases. The first one is no relational databases or NoSQL databases. So NoSQL databases are pretty much places to store data with no real structure, structureless data. We have to give them meaning, we have to give them structure. It's very common and very useful, but we are going to be learning something called relational databases. No relational databases are things like MongoDB, CouchDB. Those are some of the popular ones. But here, relational databases, pretty much SQL or SQL, depending on who you are. This is how most websites store data is in SQL databases. And pretty much what this does is this says, hey, our data has structure. That structure is relational. That means data interacts with each other somehow. And we need to store them in some way to express those relationships. Versus in a NoSQL, it's kind of just like a crowded drawer with no real organization. It's just kind of there. Do you ever go to someone's desk where it's a complete mess, but they know where everything is? Mm-hmm. That is a NoSQL database. There is an order to that. There is some structure to that. But it's very much so like I know where everything is in my life, and that's it. Powerful, right? Because it's very fast for them and very efficient. But for someone else to come into it and try to make sense of that data, there is a learning curve. Versus here, a relational database is a very organized filing system, very organized filing cabinets. Anyone can come in and see this is sorted A to Z, by date, by case, by shelf, by age, by whatever. And it's very organized, very well together. How are you feeling so far? Good. Feeling good? Cool. So let's kind of, like I said, we're not going to be doing NoSQL databases here because most of the internet runs on a SQL database somewhere. So what is a SQL database? So relational database, blah. Here's the technical definition. Organizes data into tables of columns and rows with key ending rows. Rows are called records, generally, blah, 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 blah. Blah, right? All through this, think of an Excel spreadsheet. Excel spreadsheets have multiple sheets, right? Each sheet is its own table. Each sheet has columns and rows. Each column is a piece of data. Each row is an instance of data. So let's kind of break this down piece by piece. Tables. Like I said, tables are kind of like sheets in Excel. You have one table, typically for every noun that's inside of your project. So when I say noun, let's go back to the weekend project. Right? What nouns were we working with?
users.
This weekend's project.
First name.
Employees.
Employees.
I'm sorry, employees. I meant.
Yep.
Employees.
Mm-hmm. And what else?
Phone number.
Is that really?
That's an instance.
That's a property on that now.
Company.
Company. So there's probably a database somewhere that has an employee table and a company table. So this is how kind of like the big bucket, like here's the thing. If I was building an app for a library to help them manage their book system, what tables would I have?
You probably would have
Think of the now.
Fiction.
books.
Pile of books.
Audiobooks would get its own.
Probably, yep. So books, audiobooks, videos. What else can libraries do?
It could be also aisles.
Aisles. Could, location, rows, shelves, librarians, people with memberships. So it's very high level nouns of what's going on. Those nouns have properties. What did you said something, right?
Titles.
Titles. Dante said first name for employees. These properties are going to be columns on those tables. So all the properties that these nouns have are going to be columns. These are something that every single thing has. So like every employee has a first name. Oh my God, you said it 3 times and you can't forget what it was. Title. Every. I don't know why that's not sticking. Every book has a title, right? Every audiobook has a title. So our audiobook table is going to have a column called title. It'll also probably have a column called author, also a column called spoken by, also a column called date published, length. All the properties about that thing is a column. So this weekend, you know how an employee had like 20 some columns or 20 some properties? Each one of those is a column in a database somewhere. How's it so far? Good. So columns, then the other one is a row. A row is an instance of that thing. So in our audiobook example, what's your favorite audiobook? Okay. Lord of the Rings. Let's say we have a Lord of the Rings audiobook, right? That's going to be one row inside of my audiobook table. It's going to have a value for each thing, even if it doesn't have it. Even it could be nothing, but really that's one row. Another one, the Two Towers. That's another row. Fellowship of the Ring. That's another row. The Return of the King. That's another row. The Hobbit. That's another row. They're all rows inside of the same table that have data for each column inside of that table. Just like an Excel spreadsheet, right? If I have a list of places where I'm going to go on vacation, right? I'm going to have a sheet that's per trip. I'm going to have a row that's like, oh, I can go to Canada, I can go to cruise, I can go to Italy, I can go here, I can go there. And each one's the details. How much does it cost? What's the link to book it? What's the location? What's the departure date? What's stuff like that. Right? Wow. Databases are fun and easy, right?
No.
No? We got tables and rows.
Seemed like a loaded question.
I mean, that's pretty much the basics of databases. I'm not gonna lie.
It seems organized, but I could see how that could get out of control.
Very much so.
So it's basically like an item and then a description.
Yeah.
A different.
Yeah. So like if we were to look at this weekend's project, just to give us some context, we're gonna have an employee table. Right?
Mhm.
And then this table is gonna have some columns. This is typically how we represent a table. This next part is gonna get confusing because we actually list the columns out vertically. I know. What properties did an employee have?
Address,
Address,
first name, last name.
Position.
Birth date, hire date.
birth date, first name,
Phone number.
and phone number. We'll just go with that's enough. There was another one in there that I want to say.
ID.
ID. That's a good one.
Good job.
Salary.
Salary.
and there's one other one, Josh.
Position.
Full-time or part-time?
Full-time, part-time.
Is full time, right?
Is
It is full-time.
That's what
Yeah.
I made
So-
that checkbox.
All of these are now columns inside of our database. Yes, it looks like rows to us because we think vertical and horizontal, but all these are columns. This is how we typically lay out a database table. Columns have types. So unlike JavaScript, where we can just kind of say, hey, we have a variable that's called something, we don't care what type it is, it's just a thing. Databases care what type it is. So what's the type of an address?
String.
String? Well, actually it's text. But text means string. Yeah. You'll find out that a lot of the database types are the same, just different words.
Yeah.
Yeah, I know, it's weird. Birth date is a date time. Date time, which is the specific field. First name, text.
Text.
Phone,
Number.
is it?
It's text as well.
Text.
That's fine.
It's text.
Text.
There's a lot of reasons why it should be text and not a number. Input types, it's a really big number, so we have to store it correctly. There's a lot of stuff. And typically, a good guideline going forward is if you're ever going to be doing math on a number, it needs to be a number. If you're never doing math on it, it should be a string.
Because it could be
Right.
mistakenly rounded up or.
Yeah, there's a lot of, and storage space is different as well. And also, if I put in parentheses 813 parentheses blah versus 813 dot blah 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 dot blah blah blah, or just the number itself, there's a lot of formatting stuff there.
And normally when you listen to a number, it's going to be associated with multiple other strings. So
Yeah, I'm never gonna be like, oh, take this one number and add one to it. This isn't like Verizon circa 1993.
So if you put it as a number, is it gonna like reduce it down? Is it gonna subtract?
So
Like,
it's a 10-digit number that may not be big enough.
right.
A number may not be able to store a 10-digit number. Or if it's a 1-800 number, which is a longer number, right?
or a foreign number,
Or a foreign number.
which could be like
Yeah.
15 characters long.
Yeah.
That's true.
So it's a lot of things like that. Speaking of text, we'll come back to ID. Salary is going to be a number.
Yeah.
It is going to be a double. So far we've been talking about numbers and just being one big blank thing, right? Well, now we actually have two different types of numbers. We have integers and we have doubles. Integers are whole numbers. So they're counting numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Doubles, floats, anything that has to do with like position within a decimal place. And that's a whole nother story of like precision, how precise it is, and like that. Because they could make, $10,000.50. That's not an unspeakable thing. I get a 1% raise, which boosts my salary up to something really weird and finicky. It could be a decimal. It is full time? Boolean. Those are pretty much the basic types. You notice it's going to skip over ID, right? So an ID is a field on a database, it's a column on a database that uniquely identifies each row. You noticed how when you created an employee, you got back an ID that seemingly came from nowhere, right? That's because IDs are typically auto-incrementing and auto-assigned. So the first one that was ever made is going to be number 1. The second one is going to be number 2, the third one's going to be number 3, and the fourth one's going to be number 4, and so forth. It's the order in which it's created. That really doesn't mean much because order is an order. It's a kind of an applied order. Don't get too hung up on it. It's just a way to uniquely identify the row, and that's it. Because remember, if you went to your your actual employee page, you said, hey, give me the employee with this ID, right? Yeah. So it's going to look for that employee with that ID.
Is it metadata? It's basically, is it what it falls under? No.
No, it's actually data with the row. Think about it as kind of like a fingerprint for your data. Is your fingerprint metadata about you? No. So yeah, that's it.
So if it's the fingerprint, is this like, going back to our spreadsheet metaphor, is this like column A always? Is
Pretty
like
much,
ID?
yeah.
Okay.
Typically, you have a column A that has like an ID or something like that. Yeah. Cool. How's it going so far? Anything crazy? Right? I like it. SQL is usually a fun day because it's still the honeymoon phase. Woohoo! Okay.
Our honeymoon phase is one day because I really feel like there should be a petition to like have longer honeymoons. One day is not enough time for honeymoon. It's my personal.
Usually they're like a week.
We don't have time for that. So let's head over here. Let's start talking about some tools that we have going on. So, I don't want that over here. I want you over here. Can y'all see that in the back?
Yes.
Cool. All right. So databases, this is where it gets fun. We're going to be using, so there's a whole bunch of flavors of SQL out there. Microsoft SQL, Postgres, MySQL, I'm forgetting a few, but those are pretty much Oracle. There's a whole bunch of flavors of SQL out there. Pretty much SQL, SQL, does anyone know what that stands for? Structured Query Language. All it is that just defines it's like HTML, it defines a whole bunch of set of features and how we can actually interact with things. Just like we have different browsers, right? Chrome, Firefox, Internet Explorer, Safari, they all kind of interpret that in their own unique way. Same thing with these database engines, is that they all use this SQL language, but they're all doing their own unique ways. And really, if you learn one, you pretty much learn them all. Just each one has its own little quirks. Like escape characters are different, or something like that. Quotes are different, stuff like that. It's really not a big jump to go from the next database engine. We are going to be doing Postgres. It's an open source database engine that is fast, reliable, and just all around awesome. Very popular and cross-platform, so that's even awesomer. So how do we start this thing up? So notice how I'm not in any sort of project. Don't follow along yet. Set of instructions are in your homework. So pretty much we are going to be interacting with this in the terminal. So we're going to kind of put app to bed for a little bit. We're going to put Visual Studio Code to bed for a little bit. I know.
I don't like it around.
How can we do this? This is nuts. We're going to be inside of the terminal for a little bit. So disclaimer, if you Google around and walk around, there are UI editors for Postgres. Don't use them quite yet. Right? Just as like we did Git from the command line for a couple days, so we learned what it is. We're going to do SQL from the command line for a couple days to really kind of learn what's going on. So really, I am going to start up my database. The first thing I want to do is I'm going to create a database for books. I want to store what books I have in my own private library because I'm a nerd, and I want to be able to keep track of them. So I'm going to create a new database because the first thing we always want to do when we start a new project is to create a database. After I install Postgres, I'm going to get a handy command called createdb. And I'm going to name it book collection or whatever. This can be whatever we want. This is like naming our project inside of app. Like, whatever. Yes.
Alright, so are you in a Postgres in the terminal already? Did you activate, like did you say no, it's just straight, you're straight?
After you install Postgres, Postgres is going to be running in the background all the time. What is it called? Postgres.
Okay, so createdb is like the Postgres, it's a command that's calling the Postgres that you've already installed.
Yep. This is just like app.
Right.
We're just saying, you know what, create me a new thing and call it that.
Will we be using snake case and Twitter?
For now, yes. Yeah, you notice how this is a snake case thing, right? That's how Postgres likes to see things. Because what you'll find out is that database stuff in Postgres is case insensitive.
Oh,
I know, right? So like capital B book collection is the same as lowercase b book collection, right? That's super annoying because
And insensitive.
it's case insensitive most of the time.
So
Okay,
Most
when,
of the time.
man, I was just briefly excited and you took it away. When is it case sensitive then?
So whenever you're actually querying for data, like it doesn't do case sensitive for data as well. So you still do like .2 lower cases and .2 uppers and stuff like that. But like,
Okay, that is frustrating.
yeah, but like my
If you're gonna
column
be
name,
case insensitive, just be case insensitive.
like my column name address, capital A address, lowercase a address, lowercase a, capital D, D, R, E, S, lowercase s address, they're all the same.
Okay, cool.
Yeah, right.
What is the logic behind the inconsistency of these syntax, or is it just?
It's my sandbox and I wanted to make it away.
Some developer said this is good enough to ship. And the second developer said, oh, okay, whatever. And third was like, yeah, whatever. And it just kind of grew from there. I know. If you ever want a story of awfulness, I have some stories for you of different languages and technologies that are just awful. I won't name them because I don't want to shame them in public, but we all know which one I'm talking about. I want to create this. Let's see what is happening. Remember, no news is good news. Yeah. I know.
So it's like my right.
I know. It's like,
At least like without that, be like, oh, it's doing a
It's
bunch
doing-
of stuff. This is
yeah.
satisfying to watch.
Right. Oh. So we now need to connect to it, right? Postgres gives us a command psql book collection, and this is how we connect to our database. This says, hey, we want to, hey, Postgres psql, connect to this database. And now when I run that, I'm going to get a new REPL. Things change. Oh dear, things change. And here I am. I'm connected to something called book collection, and that's it. Ta-da. Amanda?
Okay, so if there's no stuff in book collection because we just invented it
Right.
lines ago,
Right.
if there was stuff, would it show
Nope.
stuff?
Nope.
It's distressing, okay.
Yeah.
This is stressing.
So as we explore the back end more, if you're a visual person, like me, this will be kind of like what's going on. I'm a very visual person, if you haven't noticed. I like seeing things, I like being able to interact with things. This is a lot more abstract and minimalistic. I've created my database, yes, but I just see like, I think. But that's it. Yeah, you just have to kind of trust this thing to do a thing for me. And that's it.
So when we were going into terminal for things like, I want to go into Unit 2, we could ls and see the list of things in Unit 2?
Yep.
Tell me there's a thing like that.
Oh, yes.
Okay,
Oh,
thank
yes.
God.
Oh yes, and even psql is actually not the best command for this. And I'm actually going to quit this and use the real one, pgcli. Pgcli is a tool that sits on top of psql that gives us IntelliSense and autocomplete and all that good stuff. So really, pgcli book collection.
So now you're creating it again.
Nope, I'm reconnecting to it. Once we create it, it's always there forever
And ever?
and ever.
You can't delete it?
You can. So, just to show you what I mean, PGCLI comes with a lot of tools. My LS for databases is PGCLI-L. This is going to list all the databases that I've created on my laptop.
That's
Cool.
great.
Yeah, right? You can pretty much ignore this stuff. Because it's like, how's it encoded, who owns it, who has access to it, nothing too crazy. Really, the most important part is like, here's my names. Just so you know, database names have to be unique on that machine. So if I try to recreate book collection again, it'll give me an error.
Just like a regular file.
Yep, so like, if I try to do that, it says that, wah, can't do it.
If you try to do it with a capital B, it's like the same.
No, because it's case sensitive.
Worked.
Case and
Uh-oh. Right?
There it is.
Why?
So now if we want to access this one or this one, we need to wrap it in quotes and specify which one it is.
Why
No.
does it start capital letters first and then lowercase?
That's the worst.
You
I know.
get cursed out. To know
This is
it.
gonna be fun.
Can you delete one so we know how to delete them?
Oh yeah, I'm gonna delete that first one.
Yay.
Yeah. I know, right?
That's a capital.
This is crazy.
You're gonna say, yeah, we need to update the book collection database. Which one?
Yes. It is drop DB book collection.
Kinda like it.
So we can create it, we can drop it like it's hot. I don't know what I want. Whew, this is fun.
I assume the CLI is just a command line interface, or?
So let's come in here and let's create a new table because I want to store my books. Right?
So,
Question.
in this PGCLI, we're not gonna have to do select statements?
We will. We're getting there.
Yeah, we're not up to that yet.
It's a preview of coming attractions. All right. So for my books table, I'm going to tell you what columns that we're going to track to make my life a little bit easier. We are going to track an ID. We're going to track a primary author, a title, and year published. So I'm going to erase my employee. I'm going to model out my database first. This thing that I'm drawing out here constantly, this is what's called an ERD, an entity relationship diagram. It pretty much says, hey, what database tables do we have inside of our system, and what columns do they have? This is the equivalent to our wireframes. This is kind of like our plan of what do we actually want to do, and how can we communicate to our team what's going on inside of my database system. One of your assignments is going to be to create an ERD for your capstone. I know it looks something like this, right? Yeah. So I'm creating one. I'm going to call it books. All right. Books, they're going to have an ID, right? An ID. Title. I said year published.
And primary.
Yes. Year published. And primary author. Text, right?
Mhm.
Year published.
Date,
Date.
time.
I think I might set up to be a number, an integer. But yeah, date time or something like that. Whatever, however that we want to store it. Primary author.
Text.
ID is our what's called a primary key. Primary key is that formal term for that unique identifier for a row. It's auto incrementing and unique. Those are pretty much the two constraints. Typically they're numbers, but really they're a primary key.
So you don't have to be?
They don't have to be numbers, but that thing's a key, just so you know, you're aware, it's a key. Like a skeleton key?
Oh.
Yeah, right. Oh!
Oh, I like it.
Yeah, right?
Is that really like on
That's the thing, yeah. That's the thing.
the?
Yeah, that's the thing. That's our primary key, right? And yeah, primary keys don't have to be numbers, but they should be something that's unique to that thing. And typically you don't want to use a domain thing to be unique. So books have an ISBN, right?
Mm-hmm.
Right? Those are unique, right?
Yep.
Probably.
Yes, but,
Yes, but,
it's a yes, but at this point.
right?
Yeah.
Because what if it changes? What if yours been changes? What if there's two?
Because they've gotten reused at points, and sometimes you pull an ISBN, and it's like, oh, that's a thing that went out of print in 1957. That's why you're having trouble finding it.
Yes. So ISBNs gut reaction to, hey, that's unique, but they're actually not because those edge cases happen. If you're storing people have social security numbers. You know, all U.S. citizens have social security numbers, right? Those are unique, mostly. Right? There are some edge cases where that happens, clerical errors, you know, or you get a new one. So,
Someone takes your current
right? That's terrible. Identity theft is a thing. But if that's those things that are unique, but those are part of our domain structure. we typically don't want to use those for our primary key. So we could, but shouldn't. Let's create this table, 4 columns, right? Nothing too crazy. I want to say, hey, you know what? It's 10:46. Let's take our break early, because this is going to open up a big old can of worms what I'm about to do. Let's come back in 10 minutes at 10:55, and we'll keep rolling with something called queries.
I'm not especially late. I got to play my ukulele.